AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Our host brings you the leading minds in AI, sharing their story, their success, and their advice. Focusing on fast-tracking you to the top, AI in Action cuts through the hype to help you kickstart your data science career. To listen to the latest AI in Action podcast, head over to www.alldus.com/podcast or subscribe via iTunes, Stitcher, or Google Podcasts.
Hi, I'm Mike Frogger, and this is AI in Action. Today, we're joined by Victor Hanson-Smith, who is the head of Computational Biology at Verge Genomics. Victor, welcome to the show.
Hi, thanks so much for having me.
Yeah, no problem at all. We're excited to have you. So would you mind giving me a quick career background of how you started in the field and then how you came to be at Verge?
Sure. So I'm trained as a computer scientist, and maybe don't laugh, but when I was like 10 or 11 years old, I really wanted to make computer games, and that was my entry into computer science. And so
I still want to do that now. So yeah, don't feel bad about that one at all.
But I think that's a fine career. But I was really fortunate that later in my life I met mentors that opened my eyes to the wider possibilities of how I could apply computer science training. And so I went on to do a PhD in computer science, and I really went deep into evolutionary biology, using basically the approaches of supercomputing, Markov modeling to study how proteins evolved. And so that was really how I got into computational biology. So then I ended up doing a postdoc at UCSF, and I was really going deeper on those issues of computational biology and evolutionary biology. Asking questions, really basic scientific questions of like, how did life evolve? How does complexity evolve? How does multicellularity evolve? And how I got to Verge Genomics was at that time I was on the tenure track job market, looking for faculty positions. And Alice Zhang, one of the co-founders of Verge Genomics, just reached out to me out of the blue. And they had just founded the company. They had just gathered their seed money, and they were looking to build the team. And I had been wanting to get into issues of neurodegeneration for personal reasons I'm happy to talk about in more detail. And it just seemed like kind of this perfect serendipitous moment where a scientific question that was really personal to me landed in my lap. And kind of as the saying goes, luck favors the ready. So I said, this opportunity to help build a startup company doing applied science is in some ways way more interesting than me pursuing a tenure track position. So I left academia and joined the startup company, and no looking back.
I mean, how was that? How was the transition from academia to the startup world? Was there surprises along the way for you, or did you feel ready?
I felt, well, yeah, I mean, of course there's surprises. Before Verge, I had flirted with a few other startup experiences in my life. For me, the thing that is so cool and exciting about being at a really early stage startup company, it's an opportunity to wear like a dozen different hats. And so even though I had been prior to that sort of siloed in the computational biology space, by being part of growing a startup company, I was able to rapidly expand my kind of scope of vision into what does it mean to go fundraise? What does it mean to work with investors? What does it mean to think about company strategy? And a lot of these things I don't think people are kind of naturally exposed to in academia, and certainly not exposed to if they're joining larger tech companies. And so for me, I just like personally really thrive in that space where it's like I get to use all the tools in my tool belt and then like add a dozen tools on top of that, kind of out of necessity and maybe also out of joy as well.
That's great. A lot of our listenership either transitions from one part of the world to another, so either from academia into a startup or from a larger corporation into a startup, like you were saying. So just to give that some insight into that is great to do. Focusing a bit more on computational biology as a sector, what do you think makes a good computational biologist?
Yeah, I have sort of two answers to this. I think at the high level, a really great computational biologist can deliver scientific discovery headlines. And what I mean by this is, I think it's useful to disambiguate between a computational biologist and a bioinformatician, which are often sort of used synonymously. I often think of bioinformaticians being more focused on the actual tools, methods, software engineering, which is really important. I don't want to undervalue that. It's the foundation on which kind of the whole house is built. But what I see as really the differentiator in computational biology is the biology part. And the ability to not just build a cool tool, a new AI method, a new machine learning approach, but being able to then use that to discover something new and actually and add to human knowledge. When I interview job candidates, I always ask them, looking back on your career, what's the hardest problem you solved? And this question tends to be a very quick way to polarize candidates on that spectrum. So there's sort of two camps of people. The first camp is like, okay, the problem I solved is related to optimizing some method or building a new regression model or making some better machine learning approach, which is cool. But the second category is people who can say, hey, I built this new machine learning method, and then I used it to discover fill in the blank. And that second camp of people is really what we're looking for when I hire, especially at an early stage startup like we are, where we need people who can help us drive discovery.
Yeah, it's that difference between, what are you doing and why are you doing it? And people that understand the why and the business need is often the person who succeeds. So that's what makes good. What attracted you to the specific field within computational biology? I know you said that you were on tenure track and you'd already been in it for a while. Is there anything in particular that we can look to?
Yeah, I think it has a lot to do with mission orientation. When I was in academia, I was writing really cool papers. I was discovering things that were really exciting for the sake of discovery. How does life evolve? How do proteins evolve? But I felt that there was kind of a gap in how this was actually impacting the world. And so in my own personal life, my father had Parkinson's disease. And going through that whole process of just all those years of him being sick, and then ultimately kind of deep sort of spiritual question of, am I doing everything today that's like the most impactful thing I could be doing in my life? And when I kind of looked at all the skills in my tool belt, I had this powerful realization that I think the tools that I've developed could be used in a much more impactful way. And specifically, I think I have the tools needed to make an impact in making therapies for neurodegeneration. And so that was this sort of epiphany for me. I didn't know how to build a bridge from where I was to actually making drugs for Parkinson's. And so that's why when Alldus reached out to me with, hey, we have this company we've just founded, we have some seed money, we're looking to build a computational biology team. It was like almost providential because it was the answer to the question I'd been asking. And so that really was the bridge into computational biology and Verge Genomics for me. I think a lot of people in the world could have a similar story. It doesn't have to be neurodegeneration. It could be whatever problem it is that they are most passionate about. But often when I talk to like young scientists, young people in their career, and they're like, well, what should I do? Where should I apply? What should I do, with my career? My answer is usually like, well, first figure out what problem you want to solve in the world, whether it's a healthcare problem or a global problem or environment. There's like a million issues you could potentially apply your skills towards. And then go figure out who is working on that problem and figure out how to get on that team or work on that space.
It's very good advice. And life is long, so it does depend what you do, what makes you happy. So it's important. That's a good transition into what you're doing now. So at Verge Genomics, what are you guys working on?
Yeah, so Verge is a full stack drug discovery company, and we're focused on developing new drugs for neurodegenerative indications, which includes things like ALS, Parkinson's, Alzheimer's, multiple sclerosis. Our lead program is an ALS. So we've been around for almost 6 years. And so we now developed proprietary chemistry that we have patents on. We have a portfolio of drugs that are very close to entering the clinic for ALS, which has been really an exciting success story for us. About a year and a half behind that, we also have a discovery program in Parkinson's disease, which is kind of our secondary program. And then we've also banked brain tissue from a dozen other neurodegenerative indications. kind of the overall thesis of the company is that we do all-in-human discovery. So whereas traditional pharma finds drugs by doing really expensive and high-throughput screens in mouse models or other systems, we really let human tissue tell us what is going on in the disease, and we use that as our source for discovery. And then we test drugs also in human models. One of the very cool things we do is we leverage Nobel Prize-winning technology with stem cells. So one of our core model systems for testing drugs are stem cells derived from actual patients with ALS or Parkinson's disease. So rather than having to use a mouse model, which is separate from humans by like 50 million years of evolution, we can actually grow neurons in a dish from patients. This was not possible 10 years ago, and so it's really on the vanguard of what's happening in drug discovery.
Yeah, very exciting. And specifically, AI in action is this podcast. So, what are you actually using AI for on a day-to-day basis, and what part of the business does it get used mostly with?
Yeah, we use AI in two broad areas. The first is to identify dysregulated signals in patient tissue. So as I mentioned, we have minus 80-degree freezers full of brain samples from brain banks around the world. We grind up that tissue. We do high throughput sequencing. It's called RNA sequencing or transcriptomic sequencing. And what we acquire from that is a snapshot of what genes are dysregulated in the disease state. And what we're looking for is these cohorts of genes, often called gene networks, that are either up or down regulated in disease tissue versus healthy tissue. And the search for those networks involves a significant amount of machine learning and optimization algorithms. Once we've identified those signatures of genes that are dysregulated in the disease state, the second AI problem is to find what you might call master regulator genes, that if we were to maybe overexpress that gene or maybe turn that gene down, depending on the gene, we could reverse that signature, that disease signature, back to a healthy type level. And so our thesis is that if we can reverse that transcriptomic signature that we see in patients to healthy type level, we could arrest disease progression and potentially even reverse disease progression. So that's kind of the two main areas. And then there's just a myriad of methods and details within both of those areas.
Okay. I was thinking about just benefit to society. You mentioned that being, what problem are you trying to solve? Do you feel like what you're working on now, obviously if you can have an impact on disease, that benefits society, but is the way you're doing it able to be replicated and benefit society in that way?
Yeah, for sure. I think that's kind of our core value proposition. Right now it takes up to $1 billion or more to get a drug to clinic from pure discovery all the way through clinical trials. Yeah. I see this as a major bottleneck to therapeutic breakthroughs for society. This is also one of the reasons why drugs are really expensive, at least when their patent's still active. So what if we could get a drug to clinic for 10 times cheaper? What would that mean? Would that mean we can get drugs faster? Does that mean more people could get therapies faster? And so, our thesis is that by leveraging advanced machine learning and AI methods on patient tissue, using all-in-human drug screening methods, that we could ultimately get a drug to clinic for cheaper. So far, with the lead chemicals we've patented and that we're marching towards clinic, we're on track to make that dream come true. And so that to me is a really exciting vision. I think we're pioneering that vision, and I would hope that in 10 years from now, the entire drug discovery industry is on board with that. We already are starting to see that. There's a lot of other companies now that are kind of abandoning the old ways of drug discovery and moving into these more sort of sophisticated economical approaches.
Yeah, that makes a lot of sense. That's always the adage, is that every time a new drug gets approved, the next one becomes that much more expensive to do. And yeah, it's proven right. So it's a great approach. And moving into ethics within AI. So it's a big subject that gets talked about a lot. In a highly regulated space within biotech, what do you think of ethics in AI?
Yeah, I mean, the issue's real. I wish I had more solutions, but I can give you a snapshot of how I see the problem. And so I think there's kind of three areas where AI ethical issues arise. The first has to do with privacy and surveillance. And so AI enables, the rise of a surveillance state, unprecedented throughout history. And I think the real fear here is that AI could be deployed to, enable some sort of totalitarian dystopia. I know there's kind of this long-held fascination in movies, comic books, and fiction with kind of this dystopian, Orwellian, Big Brother, AI-driven state. But I think the more insidious kind of reality is more like what you might call a little brother state, which is a phrase from Cory Doctorow, in which all of the technology around us, our smartphones, web cameras, cars, web browsing habits, enable sort of a distributed surveillance state, whether it's corporate sponsored or government sponsored. And so that's already here. And so I think the question is, how do we regulate it? In biotech, we see this manifesting in how our personal genomic information, how our healthcare records are being used in ways that are maybe outside of our controls, how corporations are getting access to those records and then making decisions about what ads to show us, what products to deliver to us. And I think the real risk is if that firewall between health record security and government surveillance is breached, that it could have some real negative consequences for society.
Yeah, can agree on.
Yeah. I think that the second bin of ethics AI has to do with like discrimination and bias, and this kind of leads on from the point I was just making. And so when it comes to things like automated hiring or use of AI in hiring, judicial sentencing, college admissions. What's going on there? What happens if algorithms are discriminating against classes of consumers, maybe inadvertently, but just as a consequence of that? And so I think there's a real fear that as AI is used more to make high throughput decisions about society, that there could be really negative consequences. And so I think, one dystopian fear is that like our personal genomic information can be used to make decisions about, our healthcare, for example. If my insurance provider knows that I have risk alleles for particular cancers or other indications, what does that mean? I think so far, I want to think that the US government's been pretty good about enacting protections around that, but that's not a one and done deal. That's something that is a fight that has to keep being fought. And then kind of the third and final bucket about ethics AI has to do with something related to human judgment and the role of human judgment. And I think the question here is what happens when we outsource judgment to an algorithm? And so whether that's banking, finance, or as I mentioned, college admissions, I think on one hand, it's really attractive to think that a systematized algorithm could deploy judgment fairly across society. But I think the real risk here is that biases could exist in that algorithm and we would essentially be codifying discrimination on a massive scale.
Yeah, no, I agree. And when you just take the human element out of it, people think that they're not biased, but they are obviously. But with AI making choices, it might say, hey, for this college course, females have a better chance of success. We have a 53% rate of pass for females and much lower for males. So we're only going to let females in because we know that is going to be a higher percentage. And I think that is a really, really good point. How do we prevent that from happening? Because I feel like it already is happening with a lot of, we work in recruitment, right? So a lot of the tech that we use, it filter out people, and I think it does. So, but on that point with the recruitment side, joining Verge Genomics, you've been with the business as it's grown over the past few years. It sounds like it's going to be an exciting time going into the clinic. What's going to be growing within your team? What kind of people are you looking to on board, and what kind of careers are they going to have?
Yeah, so we're always looking for rock star or unicorn computational biologists who can come to the table with specialties in their ability to leverage systems biology and machine learning to make discovery headlines, but are also then eager to add a dozen new things to their toolkit. And that's really kind of the phenotype we're always looking for. Going forward with our company, we'll be moving into additional therapeutic indications this year beyond ALS and Parkinson's. So it's really a time of rapid growth for us. And so we're eager to find talented people who are aligned with our mission and are willing to kind of bring all of their skills to the table and also grow with us.
Yeah, I think you made some great points here as well, and it sounds like a great time to get involved with you guys and join Verge. So, Victor, if you don't mind, if people do want to reach out and get in touch, would that be all right?
Of course. Please go to our website, vergegenomics.com. There's clear links there to how to contact us. There's a list of open roles we have. And I would even say if you're interested in our mission, if you feel like you have something to bring to Verge and there's not an open position that matches immediately your skill, please reach out to us anyway. We are always interested in finding right people, even for future roles that are not listed yet.
Very exciting. All right. Well, Victor, thank you so much for being on the show and joining us for AI in Action this time.
Cool. Thank you so much.
AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Alldus offer an exec search program. Alldus can help you discover how data science and AI can transform your company. With our unrivaled network of C-suite executives and senior AI professionals, we offer retained search services across the US and Europe. Get the Alldus advantage. Become a member of the Alldus community and enjoy some of the following: AI meetups. Once a month, our community gathers to listen to some of the leading experts in the world of data science and AI. Our speakers come from all over the world, including Dublin, Boston, and Frankfurt. We also have our AI mentors. Our experts will provide mentoring to Alldus members. And don't forget our AI in Action podcast. Each week we have guests from all over the world talking us through their education, career, and more. Become an Alldus member and get the Alldus advantage. For more information and to sign up for our newsletter, log on to www.alldus.com. That's www.alldus.com. Alldus International, empowering through AI.